The E2EE client is installed locally on the user's computer, together with an object database. It is responsible for three things. It generates and manages encryption keys, locally encrypts users' data, and sends it to the remote server, which then stores it in its own database. It retrieves protected data from the untrusted domain, decrypts it, and stores it in the local storage. Alice has a document that she wants to securely store in a remote database. She stores it in the local database and asks the client to start the protection process. To generate or unlock the master key used for encryption, Alice has to provide a passphrase. The client uses the passphrase from Alice to generate a master key for her. For data encryption, the client generates a public-private key pair and a session key. Before starting the encryption process, it pulls the file from the local database. The client takes Alice's raw file and uses the session key to encrypt it. Because the session key is stored remotely, the client uses Alice's public key to encrypt it. Alice's private key will also be stored remotely, so the client finally uses Alice's master key to protect it. Finally, the client sends protected data from Alice and her public key to the untrusted database through the E2EE server. Alice's master key, which is needed for decrypting the protected data, is stored in the local storage. Now, Alice wants to share one of her protected and remotely stored files with Bob. Since both Alice and Bob are E2EE users, the E2EE component already has all of their encryption keys. There is one key missing though, a session key with which Bob can decrypt the file. First, the client retrieves Alice's protected private key from the untrusted domain and decrypts it with her master key pulled from the local database. The private key is now used to decrypt the session key retrieved from the remote storage. Finally, the client encrypts the session key with Bob's public key pulled from the remote database and stores it remotely. Bob is now ready to retrieve the shared file from Alice and decrypt it. First, the client fetches Bob's private key from the remote database and decrypts it with Bob's master key, which is stored in the local database. Next, the client retrieves Bob's encrypted session key, which is stored in the remote database, and deciphers it with his private key. Finally, the encrypted file from Alice is pulled from the remote storage, and the client uses the session key to decipher it. Bob can now pull Alice's file from the local storage. Okay, so let's see how E2EE works in practice. The upper left window shows Alice's local storage, currently empty. The window on the upper right shows the contents of the remote database, also empty. With the first command in the terminal window, we put Alice's raw file in the local database. After her file with secrets is successfully uploaded, it appears in the WITDOM storage. The next command activates the E2EE client to generate encryption keys for Alice, encrypt her secrets, and send the protected file to the remote database. Now you can see that several containers appeared in the remote storage that contains Alice's protected file and keys. Alice can then either leave her raw file in the local database or delete it. Okay, so now let's assume that Alice shared this file with Bob, and let's see how Bob can retrieve it. When we run the next command, the E2EE client fetches Alice's encrypted data from the remote storage, deciphers it, and saves it in the local database, which is now shown on the upper left side. The raw file appears in Bob's storage right after the E2EE is done. Bob can finally see Alice's secret message.